Thanks everyone for being here. My name is Elias. I'm the co-founder of Kakarot. Um, I am going to ask every panelist to introduce themselves in maybe one sentence, and we can start with you.
Hey everyone, my name's Joe. I'm the co-founder of Aztec. We're building a privacy layer for Ethereum.
Hi, Phil Kelly. I'm VP of Ecosystems at RiscZero, the guys that invented the ZK VM, and we're kind of part of Justin's Drake presentation yesterday, happily, formerly of a ZK client-side circuit company, L2con, and then at Joe Lubin's company, Consensus, before that. Great to meet everybody.
Hi there, my name is Olivier. I'm filling in for Declan, who couldn't make it today. I work at Linea, and I work on the Arithmetization.
Hey everyone. Hey everyone. My name is Jarrod, and I'm working on Abstract, which is the consumer crypto L2, contributing alongside the Pudgy Penguins team. My role is pretty much just helping people build on Abstract. So right now, just sitting on Telegram most hours of the day, answering messages.
Hi everyone, my name is Joaquin. I represent Taiko Labs, which is the first based rollup on Ethereum.
All right. So I guess the subject of this panel is making everything ZK. So as if we had like a magical wand and we can touch a piece of infra and it becomes ZK. So I'm going to ask the panelists, if you had this magical wand and you can make any piece of the infra of the crypto landscape and we can enlarge it to any piece of internet, what would you make? Only one thing, you could make it ZK today. And I'll allow scalability or privacy use cases of ZK. Yeah, let's see, what would you turn into, like Starkify, Snarkify?
Maybe I can go first. So I think about this a bit differently. In order to make something ZK, you have to have some properties of the data that you can prove against. And so the things that have been made, I guess, ZKified recently, like ZK email, the reason we can do that is because there's a signature in an email that you can prove and you can prove the authenticity of. The thing I'd want to kind of maybe ZKify would be adding a signed message to HTTP bodies. At the moment, we have to use kind of like TLS Notary, which is like, it's not a great way of getting web proofs. There have been some web standards proposed to add signed messages to HTTP bodies. If we had that, we could prove every web request without any weird trust assumptions. So yeah, signed messages in HTTP.
All right, mine's a bit more of a kind of make the world a better place answer. And I think one of the issues we've got in getting ZK adopted further, and certainly as we try and get down to the quote unquote real world in Web 2, is just understanding it. So people don't really understand what ZK is, and it's because they rely on trust today, and industry structures are based on trusted actors, and that's one of the things that causes problems. But people just don't know that they need different ways of trust and what ZK can do. So I think a really good example would be more ZK-based elections. And there's actually, it's not a completely empty space. So Estonia actually had ZK proof of the count of their election. They were able to do that because people have got fully digital identities. And basically, you can count the votes in the back room and prove to everybody you did it correctly. And I think that's kind of a very intuitive use case, and it gets people thinking about what the properties of ZK are, and then they can start to think about how to use it in different places in the world. So I kind of like that idea. Yep.
Actually, mine is somewhat close to yours, not necessarily tied to elections, but just having basically easier proof of credentials, logins, this kind of stuff, just basically having a more unified digital identity and leveraging ZK, basically.
Yeah, I think agreed with that. I think the most promising part of ZK for normies, especially, is probably proving aspects of your identity. And that kind of leads into things like KYC. So right now, if you go online, you try and sign up for some sketchy websites, or if you want to go onto Coinbase, for example, or you want to do something that proves you're an adult or proves some aspect of your identity, that you're in a certain location maybe, or you're a certain age, you have a certain degree. I think being able to prove aspects of that without providing each individual application server that a picture of your full passport, or a picture of you holding it up with a spoon on your head or something like that. I think proving aspects to applications of your identity is going to be pretty big for normies.
Yeah, I agree.
Hello.
I think your magic one works. There's a proof of passport at DevCon already, so just keep talking and we'll get more ZK things.
Not working? I broke it. Sorry. Okay, yeah. Okay, it works. Yeah, to provide a different answer, I guess I've always thought of, and it's not a very original answer because actually yesterday Justin Drake said exactly that on the Beam Chain roadmap, snarkifying the layer one, make access to participate in the consensus layer easier and making it faster, make the finality faster. It's gonna help the whole space, especially the layer choose and base rollups, which is what I represent. So I guess if I had the magic wand, I would snarkify the layer one right away.
Yeah, good answer. HTTP, I didn't have it on my radar. It's a good one. No more intermediaries, even if there are TEs. I had one question about making everything ZK. So it feels as though it's nice because we always talk about the proving aspect of ZK. Touch this, I've proven it. Touch this, I've proven it. But we tend to overlook the relationship between prover and verifier. And as soon as you assign a prover to something, you have to assign to it a verifier. And I would like to know your opinion on the challenges of, if not vendor lock-in, at least proof system lock-in when it comes to making everything ZK.
Yeah, that's a tough question. I think there will be lock-in in the sense that, so the way that like ZK proof systems work is that you normally will encode a verification key in a smart contract if the verifier is a blockchain. And so, that verification key always has a corresponding kind of proof and proving key normally. And so there is lock-in to that extent, as in one application is tied to like one particular proof system. If that application is upgradable though, it's not the same type of vendor lock-in as kind of Web 2, where they have your data and you can't leave. Because all of this is open source tech, usually you can freely upgrade your proof system over time. But there is kind of it's always paired to one verification key, which I think it does make it more challenging. So I don't have a good answer, but a bit of background maybe.
Yeah, I mean, I'd say, so if you think about so we're in the ZKVM space, and obviously everything's not absolutely as simple as the headlines, but the headline is that you can write in Rust or you can write in Solidity and drop it into a ZKVM, and then it inherits the ZK properties, and we've got verifiers on multiple chains, mainnet, Arbitrum, Optimism, Linea, Starkware, and then even Bitcoin is coming, and Solana. So in that sense, you can write code, and the same code can be ported to other ZKVMs. So there's decent amount of portability of the code. Yeah, I think typically you wouldn't have data lock-in. I mean, there will be some things I think people will customize for particular ZKVMs, potentially around accelerators, but in general, I think it's pretty flexible.
I mean, I also work in the ZK EVM space or ZKVM space, and the ZK EVMs have emerged and evolved pretty much in isolation from one another. So you have deep divergences in the way even the arithmetization works, what is being proven, what kind of version of, let's say, the EVM you're proving, and which primitives you're replacing with others. There's quite basically a fracturing in some sense. But especially if you think of the L1 adopting maybe some ZK EVM at its core, you will maybe or hopefully see some kind of convergence on some standard. And this sort of diversity of the provers as well is desirable, but you should have some agreed upon format where you can sort of interoperate easily, which may just emerge as people try to transition to a ZK EVM at the layer one.
Yeah, I don't have much to add on top of it, but I think as a general... I'm sorry. what I was going to add was, I think maybe you guys can touch on this more as well as experts, but I think as a general rule of thumb, like there's two kinds of systems. I think building for a very specific rule set. In the case of like ZK EVM, you need to essentially build, from my understanding, the circuits for each opcode, and that is kind of like the cheap way to do it, where you'll go cheap and specific. Whereas ZK VM, from my understanding, is like more broad and costly, where you can kind of go general purpose, but have more flexibility in the way that you kind of build out these systems and the proof of verify relationship. I think that's the only thing I can really add there.
Yeah, I don't have much to add from a technical standpoint, but I agree with what you said. Actually, we started as a CKEVM, and we have shifted our focus to CKVM. We just integrated RiscZero and Succinct Labs as a multi-proof system. And I guess the actual goal is to simplify as much as possible, and as Oliver said, make it standardize it a little bit, make it simple, and make it I guess faster and easier to develop, which in the CKEVM space was quite a big challenge.
Can I just say, I mean, you're getting different answers from different people, partly because ZK is such a broad term. There's so many different ways to use it. So, I mean, like Noir is more circuit-based. We're a general purpose VM. You got a ZK EVM. So, it's like really depends on how you deploy the stuff.
All right. Oop. Test. Okay, it's working, right?
Yes.
It is? Okay. If you look today, running a OP chain in production, like as an app chain, is roughly $3,000 per month. If you transition into using Succinct Labs proof system, like OP Succinct, I think it 10x's the price. So it's approximately 20K per month. But at the same time, when you look at all the app chains, they're not private. Would you rather 100x, make every ZK proof 100x cheaper, such that adoption is just more easy, or get data private? If you had to choose one today.
I'll cheat. I don't think you have to choose, because when you make something private, users prove everything on their device, so the load that the sequence is proving is a lot less. So by making it private, you actually kind of massively parallelize the kind of compute to users' devices, so you kind of get cheap and private transactions at the same time.
Also, just like to maybe extend the framing of the question. I mean, OP Succinct is not private. It is, nor would be OP based that was entirely validity proof based on RiscZero. Is a question of fast finalization, and I think building a validity chain is a really good form of fast finalization and complete certainty of transactions. And I think we will, see mass adoption of that. But we're in a situation now where the industry's getting pilled on ZK. Costs are still relatively high in some ways, but they're dropping quickly. So I think we'll probably see a period where there's a hybrid approach, and you can use Optimistic to keep costs down. You can introduce ZK for fast resolution of disputes and get the Bosa-Beth wills, and then have people moving towards full validity proofs over time. I mean, you could do sampling, for example, during the day.
I would imagine that if you have, you're able to scale, you're able to have far more efficient circuits and proving, you could actually, as a byproduct, also solve privacy issues. Just in terms of some of the privacy-related primitives are extremely expensive to sort of verify in circuits. If your ability to prove just grows exponentially, that maybe drops by the wayside in some sense.
Yeah, I think it's an interesting question. I think the answer is you don't get both. I think the beauty of this kind of L2 system that we live in today is if you want, cheap transactions and you don't really care that much about security, you can go build on Base or OP Stack or an Optimism chain. And realistically, that's what the priority is for a lot of application builders today is, they come to a ZK chain and they're like, why are my transactions 10 times more expensive than when I was building this on Base? And maybe that's like you said, people are still learning how ZK works and the trade-offs that you make for ZK today. But I think trending over time will probably have most of those chains transition to ZK as it becomes cheaper. And then as an alternative, I don't know enough about the trade-offs between privacy and scaling technology, but I think you're always going to have a trade-off regardless of what chain you're building on. You're not always going to have privacy, scalability, and cheap transactions. I think if we could have that, Ethereum would just do it to begin with. So I don't know. That's my take.
Yeah, I think the beauty of CK on layer 2s, it's not exactly the privacy feature, at least for us. It's more of its succinctness properties. So I guess to answer the question, I would say I don't think that's the real trade-off. I think if you think about it, the reason why we want CK to improve, get faster, and whatever, is not only because of the faster finality time. If we are taking OP as an example, it's an optimistic rollup, so finality takes 7 days. On CK, it takes the time that it actually takes to generate the CK proof. But not only that, if we are able to improve the CK proofs to the extent that they are generated instantly, so instant CK proofs will basically allow instant CK proofs plus search sequencing will basically allow the chains using the same sequencer with instant CK proofs to be fully interoperable, which is what is called synchronous composability. So I guess CK itself, it's usually related to privacy, which of course it has good privacy features, but I guess in the blockchain space, at least in the layer 2 space or the Taiko research space and Ethereum, it's more thought towards achieving all these, instant finality, scalability, and interoperability between rollups.
I was going to add, is it fair also to think about, because again, the Web3 market always thinks about everything kind of monolithically, but you've got different communities out there. So there are some, end user communities that will just be thrilled at Taiko running on ZK. There'll be some that will, it will make sense to them to continue operating on Optimistic for a while. So I think we kind of need to think about who the end users are.
All right. I'm going to open next question to the public. So if you have a question, raise your hand. Oh yeah, this works better actually. Okay, we have to. Okay.
Yeah, Phil is already going like, fuck no.
I was going to say but not Andreas.
Yeah, exactly. It's like everybody can ask questions but me. Just kidding. It's like Phil, I love your eye roll. That's great. Just a question to you. When do you think will we, end users really don't care about the stuff that is happening on their device as long as it's fast. So when do you think you will see ZK dedicated hardware that is coming out right now be used more broadly also for end user applications where the end user basically outsources the proof generation to a proof provider?
I mean, again, the answer is going to be different depending on who you ask and how they're deploying ZK. In our world, in the ZK VM world, having back-end proving services is pretty important, and we already have that. And we're working to have a decentralized marketplace for proof generation. And one of the benefits of that is you'll be able to plug in new proof supply easily. We integrated with Fabric. You talked about specialized hardware. We've integrated with Fabric already, and I think they're working on a release now. Don't have an exact date for it, but that's close, and that will make a big difference in terms of proving times. And you should be able to access it from anywhere that you're running the ZK VM. So I'd say that's not far off. I think there's probably a lot more that can happen in terms of hardware optimization, but the first step I think is very close.
Yeah, from a privacy standpoint, I think we're a lot further away because you have to meet users where they are with their devices, and I think you're not going to get 1 billion people a new type of chip in the next 5 years. It has to come from what already exists, and so the way I see it is like there's a lot of low-hanging fruit on devices today that we're not utilizing for like advanced proving. Like phones have really good GPUs for gaming, but at the moment all our proving systems are kind of mostly CPU optimized, and so there's been some work trying to get web GPU proving to work. The algorithms are really hard, but I think there'll be some breakthroughs on the software side first on kind of end user proving for privacy, just because of what devices we have today, and the Apple chips are getting pretty fast. So I think we'll see that on the consumer side before we see custom ZK hardware for private applications.
Yeah, that's a very good question, and I guess if I got it properly, users won't care about what's behind whenever we are able to, as an industry, whenever we're able to abstract it enough for them to not care what's going on or not realize what's going on, which is definitely a big homework that we haven't been able to do yet. It's still very complex. And I'd like to double down on Phil's point on, because you also mentioned that if I got it properly, you also asked if we think there's going to be like CK specific hardware. I guess if we boost the ability to permissionlessly prove on chains and create decentralized markets for proving, we will enable competition, and with competition comes technological advancements. So if there's profitability on generating proofs, 100% there's going to be advancements on hardware acceleration for proof generation.
Yeah, but the biggest ZK applications are going to be all on-chain. Who cares, right? Who cares about on-chain?
Why?
I have a use case where I need to aggregate like 10,000 proofs, user side. Right? It's for privacy preservation and right? So I have GPS location where I segment my journey, right? And then I need to prove the exact distance travel, right? Without revealing any GPS, right? So I can't do that on a device.
Yeah.
Right. So I need to outsource that to a quote unquote trusted service provider, and if I do that with 100,000, 1 million people that are traveling in Oregon, California, where you have to do that. Why? Because of privacy regulation, right? They can't. Everybody doesn't want to have any PII, right? Because it's a huge liability. So this is what's going to, in my opinion, what's going to drive, because we're already seeing these non-chain ZK use cases cropping up. Credentials, ZK-fying credentials, aggregating them up, right? To be able to prove one statement about myself, like with my healthcare provider.
Yeah, but that's off-chain examples. I agree with you. But there's a lot of on-chain demand for ZK proof generation.
Oh yeah, absolutely. But it's like that the scale is not going to come from on-chain.
Well, maybe you're right. But for example, it's a good point. I guess the scale is not going to come from on-chain production, unless Ethereum layer 1 is decentralized enough for what the Beam chain is trying to achieve. Get more validators to generate CK proofs on the consensus layer, but we already have it on the layer 2s. Actually, I don't like to talk about my own project on panels, but on Taiko, it is permissionless to be a prover. So we already have a decentralized market for proving. Anyone can come and prove. And we're actually seeing both on the proposers and prover side, our proposers and provers optimizing the original code that we made. Is not the hardware optimization, but it's the software and code optimization. We are already seeing them optimizing it in order to be the first to prove it and be the cheapest to prove it. So we're actually seeing advancements from on-chain proving already, and it's early.
Yeah, I think maybe to just, I agree that a lot of the demand will come from off-chain. I think there's going to be more use cases in the world that need ZK than need distributed consensus. Like, I agree with that statement, like long term, but I think to get where you need to go, I think you also need to change like proving systems and other things. Like, if you're doing like that much recursion, you probably need folding, and like I think you need to kind of, you need to like the technology is going to keep improving at like faster than Moore's law, and so maybe not today, but like give it a year, I think you'll probably be able to do your use case.
So we actually have to do it this coming year.
I think it's working now. Okay.
So we actually have to do this coming year. So
Need more ZK devs then.
Yeah, I mean, there's also things you can do to create partial proofs locally to hide some of the inputs and then get proof finalization as a service. So there's a bit more flexibility than I think like is typically discussed today. But yeah, I mean, there's definitely a way to go.
Do we have time for a last question or? Then it's one. I was just switching mic. Okay, what is one thing we shouldn't ZK?
I think it's, I don't know. I feel like a lot of the time the crypto space is pretty delusional of the use cases of decentralized technology, and like putting everything on chain or putting every ZK into everything. I think my take is ZK has pretty specific use cases right now. One is privacy and identity. I think the other main category is what we're using it for in the blockchain space in terms of scalability. Outside of that, like, I don't know, maybe I'm not letting my imagination run, but I think those are pretty much the two big categories that we see. And obviously there'll be other applications that come out down the track, but I think we probably need to prove ourselves, no pun intended, in those couple of use cases for other applications to see, oh, damn, that's like pretty dope. Let's bring across that and see how we can apply it in other fields.
Yeah, so I was going to say, I think some of the exciting things you can do with ZK in the Web 2 world are, I mean, it's basically bringing a new form of trust engineering to the Web 2 world. And to give an example of what you could do, if you're like, so let's just say you're playing, you're gambling with a Web 2 casino, you have absolutely no clue what the Web casino is doing. So you don't know whether they're running fair code, you don't know whether they're running fair code, but they're going to override it if you ever get close to winning $100,000. So, you could use ZK to have provably fair Web 2 casinos, for example. And there's a ton more things in the Web 2 world you could do like that, which is why I was saying initially, it'd be good to have a deeper understanding of the Web 2 world about what ZK can do. So it's trust engineering beyond simply, privacy and scalability. But the other thing I was going to say was it's got to be worth it. So Web 2 Casino is a really good example. ZK, Sudoku or Wordle, like we see that quite a lot, and it's a really good way of getting people to understand, and they're like good tutorials. But it's not worth it because it's more costly compute, so there's got to be a real reason for it. And it's also got to be workable. So, I mean, maybe an unpopular opinion, but I'm a bit skeptical about being able to do any ZK ML meaningfully in the near future because, ZK is not great with floating points. And, I mean, we can now handle huge problems in ZK VM. But, for example, proving inference in learning, I think is, beyond the capabilities any time in the next few years.
You can probably prove something's a cat, but you're not going to get a large language model kind of proof. I mean, I think my take, if you're using kind of the actual zero knowledge properties of ZK, we get a lot of people trying to kind of like take something that's public and just being like, I'm going to add ZK and it's just going to be private. And there's just a lot of misconceptions there. Like the common one is Uniswap. Like it's the ratio of two public numbers. Like those numbers have to be public for it to work. And so like you can't ZK-ify something that was designed to be public. If you want to get privacy, you have to kind of go back to the drawing board, redesign it, and think about it that way. So I think, yeah, that's my one. I think is, it's not. You can get verifiable compute and prove that Uniswap executed correctly, but you can't just add privacy to it.
I really don't know how to answer. To be honest, I think it's a very good question. Why we should not ZK. But the reason why I don't know how to answer is because hello, I'm breaking all of them. Sorry. The reason why I don't know how to answer is because it keeps surprising me the use cases that it enables all the time. Like, I don't know, on top of my head to think of one example. I recently heard in a random podcast, I don't even remember which one it was, a project that is working on proof of authenticity for newspaper pictures. So apparently there's a whole industry about, there is a random news and there's a picture attached to it, for example, talking about war or something. And turns out it's very normal that they fake, like the picture doesn't represent what the article is talking about. And turns out ZK can help solve that. So I really don't know how to answer what we should in ZK, because maybe in 1 year I find out that there's a use case exactly for that.
So you don't want to be wrong.
Yeah, I don't want to be wrong.
I also agree. I mean, it's hard to know what will be relevant use cases. So I wouldn't say that there's anything one shouldn't ZK, but there's certain things that you don't want to ZK, where you'd rather basically, for instance, if you think of like the trend in the ZK EVM space is towards type 1 ZK VMs. Type 1 ZK VMs currently means a lot of ketchup. In some sense, you would rather the protocol evolve towards more crypto-friendly primitives from the get-go, and basically shift the meaning of what it is basically to be a type 1 ZK VM. So I hope we don't have to go down the route of, well, and I expect we won't, of basically proving ever more ketchups, but having maybe just a better or base sort of protocol that is more friendly from the get-go.
One for illusion, because we're at type 1. I agree with you. I hope we don't, I mean, I think this was, I'm coming back again to Justin Drake's talk yesterday, which was very interesting. You mentioned, for example, ketchup hash function is quite inefficient, and you hope we don't have to go down the road of having to use that hash function because of its inefficiency. I agree, and I hope Ethereum itself is the one that leads with example, and I think Justin mentioned, maybe I'm wrong, correct me if I'm wrong, but I think he mentioned changing it to Poseidon, which is much more efficient. I don't know if it's Polygon, the one that developed it at the first time. So yeah, I guess changing the definition of type 1 to a more efficient type 1-ish is the key, even though not being a type 1 comes with a lot of trade-offs, of course. So, yeah, I agree.
All right. I'm checking time, but I think we're good. What's your stance, like bearishness, bullishness on ZK analog tools like a ZK microphone, and I somehow sign my voice and I can prove that I'm not speaking to you from ChatGPT 4.0, or ZK camera that says that my stream is not a VTuber stream? What do you think? Do you think that's going to come anytime soon, or it's too easy to civil, or it's impossible to just manufacture at great length?
I think these tools will become more important, especially as AI. It's kind of like ZK is defensive technology against AI. Like I think that's kind of like a common kind of thought now. I don't think we're there today where you can actually credibly prove your voice. Like someone can do it at a hackathon, but what they're actually doing is I don't think you'd have confidence that if I heard two voices and one of them had a proof with it, that the proof wasn't generated by ChatGPT to just convince me. I don't think we're at a stage where it's credible yet, but I do think over time, those initiatives, as proving does get faster, will become pretty meaningful. It may be limited to kind of, not personal podcasts, but is Trump actually speaking? That sort of thing, and a government style kind of thing initially, but I think that will become commonplace in the next 5 years.
I think some of those, I mean, you can do all kinds of stuff with ZK, but you also have to think about whether it's the best and the right approach to some problems. And authenticity to some extent can be solved by simple signatures. without ZK. So like, here's a picture. It's signed by this chip. We're done. There's a role for ZK on top of that. For example, here's a picture. It's signed by a chip. It's from this range of cameras, and I can prove that it's reading from that. But I'm not going to tell you exactly who signed it. Yeah, to preserve privacy.
Programmable credentials.
What's that?
Programmable credentials, something like this.
Yeah, with a privacy layer over it. And then also, for example, I mean, the other issue is so much manipulation happens anyway. Like when you take a picture with your iPhone, the one that you see on the screen has already been through a bunch of enhancements. So it's not the raw image anyway. And so you might want to use ZK to prove that the manipulation that happened with the right program. So there's a role there, but yeah, there's a lot of things you can do just with regular cryptography, I think, rather than ZK.
Do we still have time? Okay, nice.
Yeah, I'll just pretty much was gonna say the exact same thing. I think like you don't really need ZK proofs to do a lot of things. Like today, you're already proving your identity. Like if you make a commit and push it to GitHub, you need to like sign it with cryptography. You're not using zero knowledge proofs to say, hey, it was me that actually made this code and pushed it up. There's already mechanisms in place that allow you to prove that you did something or you performed a certain action. And yeah, I don't think you really need ZK for a lot of it because the cryptography already exists there.
Okay. Yeah, I had one last question, and it's about, for example, you mentioned the beam chain. I think it's interesting because we've heard a lot of people talk about switching from Keccak to a ZK-friendly hash function, so more ZK-friendly primitives on layer 1. And the reason that there was pushback on Poseidon is because we don't know that it's stable enough yet. And how about proof systems that kind of very good cryptography teams have been building, but kind of in isolation? So I would say like Starkware has built their Stark protocol, Linea has built their own, RiscZero has Zero Stark. But so these systems, we're saying, we're proving stuff. So we are trusting those systems to represent truth. So how long does it take for L1 to switch to Poseidon? Like maybe 20 years. So will it take 20 years, 10 years for people to trust ZK systems such as the ones you've built? It feels like what I'm trying to get at, the idea is we are trusting a lot the reality that ZK proofs gives us, and we are not questioning enough if the proof systems are sound. And because they've been built, and they're incredibly hard to build, I would say less than 1,000 people can build them in the world. And then those people are so busy building their own that it's hard for them to assess if the other ones are working because they're like black boxes in some sense. So how do you resolve this tension?
Yeah, very good question. I guess that's why, at least in the short term, maybe even medium or even long term, multi-proof is very important because the different ZK proofs are generated in isolation by different teams, and it's very unlikely that the same bug is that you can find in one of them is exactly, it can be found on the other one because it's different. So I guess the short-term or medium-term solution is having multi-proof and having a backup if you find a bug in one.
I think I don't think it's working. Yeah. I think maybe this is where L2s can come into play. If I'm not mistaken, like a couple of different L2s are already doing this today, like replacing non-ZK friendly hash functions with more so friendly hash functions. And yeah, maybe that's the play, like do it on the L2s where, currently there's like way more centralization, way more recovery. Like you can pretty much stop the chain if you want to on the L2 today. And maybe that's the path, is like use it as a playground before we take it to the L1. That's one option.
It is an extremely difficult problem, I would say, and for which I don't believe we have any sort of real solution. One long-term or one more satisfying sort of resolution of the query of what does it mean that you proved something, because the proof system is extremely constraining when it comes to allowing you to basically express something. But it's very difficult to understand the consequences of your constraints and what is actually a valid trace and what is expressible. It basically, as soon as you get to the dozens or the hundreds or the thousands of constraints especially, your ability to reason about the system breaks down completely, and you work on assumptions that may not be satisfied. It gets very, very thorny very quickly. So I think, in some sense, a long-term solution, which has many problems in and of itself, is formal verification of those systems. But even that, it's sort of unclear, certainly to me, what that really means. Like, you have canonical references for the EVM, for instance. You have the execution specs. But getting the execution specs to communicate with your arithmetization or even your writing of the circuits in a higher level language is not a trivial task. You have a lot of obviously testing and sort of generating tests that sort of can give you great confidence that what you are proving is very close to what the EVM should be doing. But all in all, it's to me it's the great sort of problem of the space in my sense. Yeah, sort of really understanding what it means, what having a proof really means.
Yeah, I mean, formal verification is a great initiative. The other thing I'd say is, and I think this is true in the software industry in general and has been for decades, the more that you can standardize things and the more that you can get, the whole industry looking at one set of code or a small number of sets of code and can battle test it, and the more you can abstract away from changing that code and build things on top of it, the more that you can have this known, highly tested, highly scrutinized set of code as a basis for everything. And that's why I think ZK VMs are really valuable for the industry, because they're middleware, and that's how every software industry goes. You start off with a lot of custom code. It's really expensive to write. It introduces security risks. It's much harder to audit. And then as things get standardized, you get this layer. Everybody can use it. Everybody can share the cost of it, and you just build the new clever stuff on top of it. So I actually think ZK VMs are really important for security reasons and cost as well.
Yeah, I definitely second that. I think the reason we have so many proof systems today is because we haven't reached like a performance floor. And so when we reach like a performance floor that works for everyone here, like there is like the incentives don't make sense to build your own. You just pick the one that's audited and off the shelf and kind of make it better, especially if it's open source. But we're just not quite there today yet. Like the performance is still going like this. And so, people are trying to pick when to stop, and there's still quite a lot of gains on the table. I think the only other thing I was going to say is, the multi-prover, or kind of even simpler, just having training wheels, like Vitalik says, like where you have like a committee that signs off on the same transition as the proof's trying to prove. They have to agree for the state changes to go through. I think rollups should probably have that for the foreseeable future as well. And yeah, just lots of time is the only other thing. Like time is the only thing that kind of makes your bugs go away. So we gotta wait.